Hi class, welcome back. Maybe you took a little break in watching these videos. If not, then let's just keep going. So we've been discussing section 1.1 of our textbook about functions, and now we're going to do a little bit more computations, practicing the function notation, and doing evaluation of functions and combinations of functions. So for number 6, we're going to let our function be y equals 2x squared plus 1. So you can think that unless it was already given another name, we could name it f of x. And so this is wanting f of 1. So what that means is, again, wherever we see the x in the equation, which is just here, we need to replace it with a 1. Okay, so f of 1, that doesn't mean like f times 1, because f is not a number, f is just the name of the function. It's saying that wherever you see x in the equation, replace it with the value 1. Okay, so it's 2 times 1 squared plus 1. So this is 2 times 1 plus 1, which is 2 plus 1, which is 3. Okay, so f of 1 is 3. Or in other words, when x is equal to 1, y is equal to 3. Okay, let's find f of negative 2. So again, wherever I see the x in the equation, I must replace it with negative 2. So I have 2 times negative 2 squared plus 1. So that's 2 times 4 plus 1, which is 8 plus 1, or 9. So when x is equal to negative 2, y is equal to 9. Okay. So next we're going to do f of x plus h. So remember, I'll keep it here. F of x equals 2x squared plus 1. Okay, so I can kind of, if I want to, I can think that wherever I see the x, which is only here, I'm going to have my rule that lets me know what to do with it. Okay, so let me change back to my black pen. Okay, so here now it's asking me for f of x plus h. So what that means is that wherever I see the x here, I need to replace it with x plus h. And so that means that wherever I see the x here, I need to replace it with x plus h. And it's always safe to keep it inside of parentheses. Okay, so what I'm saying is that f of x plus h is going to be 2 times x plus h squared plus 1. That's what it is. And then if I want to, I can expand that because I know that x plus h squared. So if you need to have a scratch paper, then do it. X plus h squared means x plus h times x plus h. And so then you can like multiply it all out together, and then that would be x squared plus hx plus xh plus h squared, or x squared plus 2xh plus h squared, yeah? So totally, that's just this one. So I have 2 times x squared plus 2xh plus h squared plus 1, which is 2, I have to multiply the 2 to everything inside the parentheses, 2x squared plus 4xh plus 2h squared, and then plus 1. The 2 isn't multiplied by the 1. So this would be the simplified version of the answer for f of x plus h. Okay, and then now in number 4, we're building on this. It's asking us to find f of x plus h minus f of x over h. This is the so-called difference quotient. You guys will use this a lot when you go into calculus because this represents basically like a rate of change. Okay, so this is saying that you need to first find f of x plus h, so this here, what we found in the previous problem, and then you need to put that into this entire fraction. So if we hadn't have found f of x plus h yet, we would have to find it as the first step, but we did already find it, so I can take that value, 2x squared plus 4xh plus 2h squared plus 1. That's f of x plus h, and then I need to minus off f of x. Remember, f of x is 2x squared plus 1. and this entire thing needs to be divided by h. Okay, so what we see is that we have 2x squared minus 2x squared, so those two things add together to be 0, and then also we have 1 minus 1. Oopsie, sorry. So those two things also add together to be 0, and so totally what we have left is 4xh plus 2h squared all over h, and you'll notice that we can actually factor h off the numerator, so I have 4x plus 2h after this factoring divided by h, and then when you look here, h over h is equal to 1. And so in the end, this so-called difference quotient is equal to 4x plus 2h after simplification. Okay, so you have to be aware that you can plug in expressions into functions, not just numbers. So now when I want, for example, f of 2x, that's saying that we need to take our equation for our function and plug in negative 2x wherever we see the x. Okay, so that will be, by order of operations, negative 2x squared. If you need to do it on your scratch paper, do it, but that's negative 2x times negative 2x, which is 4x squared, and plus 1. I can multiply by 2, and I would have 8x squared plus 1. The 2 is not multiplied by the 1. So please always use parentheses very carefully. Okay, we're just going to have to do more and more examples, and of course when you go and do your homework, you will also do more and more examples. That's important to practice. Okay, so now we have the function f of x equals 1 over x minus x. So in this case, there's x going to 2 spots, not just 1. So when I have to find f of 2, I'm going to have to take the 2 and put it into both places. Okay, so f of 2 is 1 over 2 minus 2. And that's the same as 1 over 2 minus 4 over 2, which is equal to negative 3 over 2. So when x is equal to 2, y in this example is equal to negative 3 halves. So then if I want to find out what f of a plus b is, wherever I see the x, I just replace it with a plus b. So it's 1 over a plus b minus a plus b. So remember, you can always think of there being a parenthesis around the x. That can help you to know, because I need to put a parenthesis around the a minus b, because this minus sign will actually distribute. If I forgot the parenthesis, my answer wouldn't be right. So in other words, what I'm saying is that this is the same as 1 over a plus b minus a minus b. Okay, so that's my answer. And f of 0. So I go to plug in the 0. I have 1 over 0 minus 0. However, 1 over 0 is undefined. I cannot. This is undefined to divide by 0. So what that means is that f of 0 is undefined. I cannot find it, okay? I cannot divide by 0. And so this is actually a helpful trick for dealing with domains. You can't divide by 0, so anytime you're dealing with a function with a denominator and you're asked to find the domain, you have to look and see what value of the denominator is 0, because then that won't be allowed. Okay, so here, what's the domain of f? So remember, f of x is 1 over x minus x. So you got to think like, okay, x is the independent variable. What value of x can I plug in this function? And the subtracting is okay, but the dividing is not. So you would say, whenever this denominator is 0, then the function is undefined. So, and that's the only time the function is undefined, the domain would be the set of x in the real numbers such that x doesn't equal to 0. Okay, that's the domain. Let's see another example of domains. So in this example, I have the function g of x, which is x divided by x squared minus 1. And the question is 0 in the domain of this function? So that's saying, can I plug in 0? So let's try. If I plug in 0, I would have 0 over 0 squared minus 1. That's 0 over minus 1. Well, that's allowed because 0 is on the numerator, not on the denominator. That's equal to 0. So that means that yes, 0 is in the domain of G. Okay? Now, that's just one point. Also, we want to know what is the entire domain of G. So that means what are all the possible values of x that I can plug in? So take a look. Well, I'm going to have a problem when the denominator is 0. So that's letting me know that as long as x squared minus 1 equals 0, x will not be in the domain. I can add 1 to both sides. So this is saying that x squared equals 1 is not allowed. And then I can take the square root of both sides. So x equals plus and minus square root of 1, which is equal to plus and minus 1, is, sorry, not allowed. So that means that the domain is the set of x in the real numbers such that x does not equal plus and minus 1, because those values make the denominator equal to 0. Hopefully that helps you to understand domains a little bit better. Okay, so now we're going to look at another type of function called a piecewise defined function. This is a function that's defined in pieces. Okay, so this function, y equals f of x, it's basically two situations. Okay, so if x is greater than or equal to 1, we plug x into the function 1 over x. And otherwise, if x is less than 1, we plug it into the function x squared. Okay, so the first question is find the domain of f. So we have to look at each of these pieces individually. So if it's 1 over x, I know that the denominator can't be 0. But if you look here, that's actually not going to happen because we only plug in the first situation when x is greater than or equal to 1. And so 0 will not be a problem. And for the second situation, x squared, there are no numbers that we can't square. So really, there's no restrictions on the domain. So this one, the domain is all real numbers. Even though it has 1 over x, we don't plug in that situation when x is 0. Okay, so let's also find f of negative 5. So this is just one extra step. You have to look and see basically which situation am I in. When x is equal to negative 5, you have to think, is it bigger than or equal to 1, or is it less than 1? Well, negative 5 is less than 1, so we're in the second situation. So that means I have to plug into this formula. So f of negative 5 is negative 5 squared, which is 25. So after you figure out what situation you're in, then you just use the given equation and replace everywhere the x with the value you're given. So we can do another example, f of 0. So again, we look and see what situation we're in, and we're like, is 0 bigger than or equal to 1, or is 0 less than 1? 0 is less than 1, so we have to plug into this formula, okay? That's again why 0 is allowed, because this will equal to 0 squared, which is 0, okay? You see the next one is asking for f of 1. So then we go back again, and we ask ourselves, what situation are we in? So when x is equal to 1, is that bigger than or equal to 1, or less than 1? 1 is bigger than or equal to 1, so I should plug into this formula. Okay, so f of 1 is equal to 1 over 1, which is 1. Okay, so that's an example of a piecewise defined function. Those will also be very important in calculus, and yeah. Okay, so another example of a piecewise defined function is the absolute value function. Sometimes we write it like this too. That's just another way of writing the function. And this function depends on whether your input is positive. If so, you just return the same input, or if it's negative, you return the negative of it. So the first thing is to find the domain of this function. But you see both of these equations, I'm allowed to plug any number in. There's no denominator or any problem. So the domain of this function is all real numbers. I can plug anything I want in. Okay, so let's try to plug in -3. Which situation am I in? -3 is negative. So then I plug in to this formula. So I take the negative of -3, which is 3. Okay, you might have a different way of thinking about absolute value if you've seen it already. Maybe you don't think of it as a piecewise defined function, but whatever intuitive way you have still matches the answer, yeah? This is a different piecewise function. Okay, now f of 0, we're in the first situation because 0 is greater than or equal to 0, so then I just plug 0 in this equation, so I literally return 0. Okay, and then lastly, when x is equal to 4, you get to figure out that you're in the first situation, so you plug into the first function, and you just return 4, okay? Alright, so that's piecewise functions, and then we do have to speak about combining functions in similar ways that we can combine numbers. So definition 2. We can combine functions to create new functions. Let f of x and g of x be the names of two functions. Then the new third function called the sum f plus g is defined in the natural way by f plus g evaluated at x is equal to f of x plus g of x. Similarly, the difference f minus g is defined by f minus g of x equals f of x minus g of x. The product f times g is defined by f times g of x equals f of x times g of x. And the quotient f over g is defined by f over g of x equals f of x over g of x. So for example, in number 10, we can consider the function f of x equals 2x squared plus 1, which we've seen before, and another function, let's call it g to give it a different name so as not to be confused. G takes the input x and returns the output x minus 5 all over x. With this information, we can find the following. For example, f plus g of x. By the definition, this is equal to f of x plus g of x. Now, that's by the definition of sum. Furthermore, by the definitions given on the line above of f of x and g of x, we can state that this is equal to, so f of x is 2x squared plus 1, and then g of x is x minus 5 over x. So totally, this is equal to f plus g of x. Observe, an input of x, a variable, produced an output of a function. Contrast this with part B, which is asking for f times g of 4. Since I'm putting in a number, I'm going to get out a number. Okay, so you have two options. Like one, you can find f times g of x, like what we did earlier, and then plug in x equals 4. Or, this is what I'm going to do, you can find f of 4 and g of 4 and multiply them together. What I mean is that by the definition of product, this is equal to f of 4 times g of 4. And so I know how to find f of 4. I just take the 4 everywhere the x is in the equation for f. So this is f of 4, and I need to multiply it by g of 4. So again, wherever I see the x in the equation for g, So I'm going to replace it with a 4. So this will be 4 minus 5 over 4. That's g of 4. And then whatever number this is, I can just simplify it down now. So 4 squared is 16. So I have 2 times 16 plus 1. And then 4 minus 5 is negative 1 over 4. So 2 times 16 is 32. And then plus 1 is 33. So this is negative 33 over 4. Okay, so when your input is a number, then your output is also a number. Okay, we can also do something like find the domain of f over g of x. So this is equal to f of x over g of x, and we can say what this is. So this is 2x squared plus 1 all divided by g of x. So I'm going to put a parenthesis because g of x itself is a fraction. So I'm dividing 2x squared plus 1 by x minus 5 over x. So this is the same as, let's change it into a more simple fraction. So this would be 2x squared plus 1 times x all over x minus 5. And remember, what we're trying to find is the domain. So we should look on the denominator and make it not be 0. So the only value for which this expression will be undefined is when x minus 5 equals 0, or in other words, adding 5 to both sides when x is 5. So the domain is the set of all x in the real numbers such that x does not equal 5, okay? So that's the domain. Okay, now we need to do f minus g of 2x. So we're like combining the two situations. So this will be f of 2x minus g of 2x. So I have to put 2x in for f and in for g and subtract them. So this will be 2 times 2x squared plus 1, that's f of 2x, and then I'm going to subtract off g of 2x, which is 2x minus 5 over 2x, okay? We could slightly simplify that if we want to, because we know that 2x squared is the same as 2x times 2x, so 4x squared, and then when we take the 4 times the 2, we would have 2 times 4x squared plus 1, and then if I want to, I can take that minus sign and distribute it, so I would have 5 minus 2x over 2x, and so this is the same as 8x squared plus 1 plus 5 minus 2x over 2x. Okay, and then lastly, for part E, you can even have something plus itself. So this would be f plus f of x by definition, f of x plus f of x, which is equal to 2x squared plus 1 plus 2x squared plus 1. So totally 4x squared plus 2 after it simplifies. Okay, so this is an optional problem. You can work on it if you want. I would say, like, maybe let's just do one difference quotient together, because that is pretty important, and I usually put that on the test, and the rest of this is just if you need practice. Okay, so in this example, g of x is 2x plus 3, and we're going to find the difference quotient g of x plus h minus g of x all over h. So step by step, first we find g of x plus h. So that means that in this formula, where I see the x here and here, I need to totally replace it with x plus h. So it's going to be 2 times x plus h plus 3. Okay, so 2 times x plus h plus 3. What I just wrote is g of x plus h. Okay, and then I need to subtract off g of x, which is 2x plus 3. See how I'm being careful with my parentheses? And then this whole thing has to be divided by h. Okay, so let's simplify a little bit. Oopsie. So this is going to be, when I take the 2 and distribute it here, I would have 2x plus 2h plus 3. And then when I take the minus and distribute, I will have minus 2x minus 3, and it's still all over h. So I'm going to look and see if anything cancels. 2x minus 2x equals 0, and 3 minus 3 equals 0. So at this point, we are only left with 2h over h, and h over h is equal to 1. So totally, the difference quotient simplifies quite a lot, as they often do, all the way down to 2. Okay, so we finished section 1.1 now. Go ahead and take a look at the homework on my math lab. Don't hesitate to contact me with any questions, or you can ask them in office hours or in class next week. I look forward to meeting you guys in person.